Limit test. Video lecture presented by Mrs. Afroz Pathan, Assistant Professor, Department of Pharmaceutical Chemistry and Analysis and School of Pharmaceutical Sciences. Limit test. These are quantitative or semi-quantitative tests designed to identify or control small quantities of impurities. These tests should be specific and also sensitive. The apparatus which is used for doing limit test is Nestle cylinder, which has 50 ml or 100 ml mark made up of pure glass. The general principle involved in limit test is, if the sample intensity is lighter than that of the standard, then it is said that the impurities are within the pharmacopoeial limit and the sample is accepted. If the sample is darker or heavier than that of the standard, then the impurities are above the pharmacopoeial limit and the sample is rejected. General precautions to be taken when we do limit test. The liquid must be clean and filtered if necessary. The Nestle cylinder must be made up of colorless gas and of the same inner diameter. Detecting opalescence or color development must be performed in daylight. When comparing turbidity, it should be done against black background, whereas when comparing the color, it should be done against white background. Coming to the limit test of chlorides. Generally, this test is done to control the chloride impurity in any inorganic substance. And the principle depends upon simple reaction between silver nitrate and soluble chloride to give insoluble silver chloride in presence of dilute nitric acid. The insoluble silver chloride makes the solution opalescence, and the extent of opalescence depends upon the amount of chloride present in the substance, which is compared with that of the standard opalescence. Generally, it is produced having a known amount of standard substance dissolved in a particular solvent. Coming to the chemical reaction of chlorides limit test. So here the soluble chlorides, when reacted with AgNO3, it will form AgCl, which will form precipitate and gives opalescence to the solution. How to do the procedure for limit test for chlorides? Take two Nestle cylinder, one is test and one is standard. To the test Nestle cylinder, add 15 ml of sample, and to the standard Nestle cylinder, add 10 ml of standard chloride solution and dissolve in 5 ml of water. To both the Nestle cylinder, add 1 ml of HNO3 solution and make the volume up to 50 ml mark. Then to both the Nestle cylinder, add 1 ml of AgNO3 and stir with glass rod and keep it aside until the opalescence forms. Compare the opalescence of the test with that of the standard. If the opalescence produced in the test is less intense than that of the standard, then sample passes the limit test for chloride, and otherwise vice versa. Importance of dilute nitric acid in chloride limit test is, dilute nitric acid is used to prevent the precipitation of other acid radicals with silver nitrate solution. It acts by providing common ion effect. Limit test for sulfates. The principle is based upon simple reaction between barium chloride and soluble sulfates in presence of hydrochloric acid to produce insoluble barium sulfate, which will produce opalescence to the solution. The comparison of turbidity with that of the standard is obtained by dissolving the known amount of sulfate in same volume of dilute hydrochloric acid in both the solutions. The reaction is as follows. So, the soluble sulfates reacts with barium chloride to produce insoluble barium sulfate, which will produce opalescence to both the Nestle cylinder, test and standard. So, how to do the procedure? Take 15 ml of sample in Nestle cylinder, test, and take 10 ml of standard solution, dissolves in 5 ml of water. To both the Nestle cylinder, add 1 ml of HCl each and make the volume up to 45 ml mark. Then add 5 ml of barium sulfate reagent to both the solutions, stir and keep it aside till the opalescence forms. The opalescence in the sample and the standard are compared by keeping the Nestle cylinder against proper background and observing side by side. If the test opalescence is less than that of the standard, then it is said that it passes the limit test, otherwise it fails the limit test. In IP, the barium chloride has been replaced with barium sulfate reagent, which consists of potassium sulfate, barium chloride, and sulfate-free alcohol. The importance of each ingredient is as follows. Potassium sulfate has been added to increase the sensitivity of the test, and the ionic concentration in the reagent has been adjusted in such a way that the solubility product of potassium sulfate gets little bit exceeded also, it will undergo precipitation. Hence, potassium sulfate acts as a seeding agent for the precipitation of barium sulfate. And alcohol helps to prevent supersaturation and thus produces more uniform opalescence. And barium chloride is useful for the precipitation of barium sulfate. The substance passes the limit test if the turbidity is less than that of the standard, otherwise vice versa. And the HCl which is we are using, use it to prevent the reaction of other acid radicals with barium chloride. In presence of HCl, only sulfates undergo precipitation. Coming to the limit test of iron. The principle is based on formation of pale pink to deep purplish color by the reaction of iron with thioglycolic acid in presence of citric acid, where the solution is made alkaline with ammonia solution. The color is due to the formation of coordinate compound, that is ferrous thioglycolate, which gives pink or deep purple color to the solution. The original state of iron is immaterial since thioglycolic acid reduces only the ferric into ferrous state. Coming to the reaction, if you see here, the ferric iron reacts with thioglycolic acid and converts into ferrous iron. The ferrous iron form complexes with thioglycolic acid to give a coordinate complex, that is ferrous thioglycolate, which gives purple color or pale pink to deep purplish color. So how to do the procedure? Take 10 ml of sample in test Nestle cylinder and 2 ml of standard iron solution in standard Nestle cylinder. Both the solutions are made alkaline by using ammonia solution, and make the volume up to 40 ml mark. To it, add 2 drops of thioglycolic acid and 2 ml of 20% citric acid in both the Nestle cylinder and make up to 50 ml mark and keep it aside for few minutes so that the pink or purplish color will be obtained, which is compared with that of the standard solution. The importance of citric acid in limit test for iron is, citric acid is added in the official process to prevent the precipitation of iron by ammonia. Iron gets precipitated in the form of ferrous hydroxide or ferric hydroxide depending upon the oxidation state of iron in the ammonia. As citric acid forms soluble complexes with iron, ammonia is not able to form precipitated with iron and it is used only to just provide the alkaline condition. Limit test for lead. The principle is based on reaction between lead and diphenyl thiocarbazone, which is also called as dithiazone in alkaline medium, to form lead dithiazoate complex. The lead present as an impurity in the substance is separated by extracting an alkaline solution with dithiazone extraction solution. The interference by other metal ions is eliminated by adjusting the optimum pH for the extraction by using reagents like ammonium citrate, potassium cyanide and hydroxylamine hydrochloride. So the reaction is as follows. Lead, when reacts with this dithiazone, actually which is green in color in chloroform, leads to the formation of lead dithiazoate complex, which is violet in color. The intensity of violet color of the complex depends upon the quantity of lead present in the solution. Hence, the test color is compared with that of the standard color. Limit test for arsenic. The principle involved in limit test for arsenic is based on reduction of arsenic in arsenous state to arsine gas in presence of zinc and hydrochloric acid. The arsine gas produced will stains mercury chloride paper into yellow, which is compared with that of the standard. This is clearly explained by using a chemical reaction. So, the arsine, which is present as an impurity when dissolved in acid, will produce arsenic acid. The arsenic acid is reduced to arsenous acid by reducing agents like stannous acid and potassium iodide. And the nascent hydrogen, which is produced during the chemical reaction, reduces arsenous acid into arsine gas. The arsine gas reacts with mercury chloride paper to produce Yellow color stain. The depth of the yellow color stain depends upon the amount of arsenic present in the sample, which is compared with that of the standard stain produced by the low amount of arsenic. The general apparatus which is used for detection of arsenic limit test is Gouget's test. So explanation of that apparatus is also very much important. The apparatus is made up of wide-mouthed glass bottle of 120 ml capacity having a mouth of 2.5 centimeters in diameter. This bottle is fitted with a rubber plug through which the glass tube of 20 centimeter long having an external diameter of 0.8 centimeter and an internal diameter of 0.65 centimeters is run along with that tube. The tube is constricted at the lower end extremely at about 1 mm in diameter, and there is a blowhole which is 2 mm in diameter by the side of the tube near to the constricted part. That is useful for escaping of water vapor or other gases. The upper end of the tube has been fitted with two rubber bungs made up of 25 mm in diameter, each having a bore hole centrally exactly of 6.5 mm in diameter so that it holds the upper end of the tube, while the second bung has been fitted upon the first bung in such a way that mercury chloride paper gets exactly sandwiched between the central perforation of two the bungs. So all the ingredients means the chemical reaction required for the limit test for arsenic, that is arsenic, zinc, stannous chloride, everything is added in this 120 ml capacity beaker. And when the reaction occurs, the gases which are being evolved, especially arsenic gas, is passed through this narrow tube of 20 centimeter long, and the gas will enter into mercury chloride paper which stains it. The importance of cotton plug which is dipped in lead acid is to entrap the gases other than arsenic which are about to produce in the chemical reaction. Especially hydrogen sulfide gas is entrapped by using this lead acetate cotton plug. So the yellow color which is stained in the mercury chloride paper of test is compared with that of the standard. So based upon this, how much amount of arsenic is present in the test is found out. Thank you one and all.